Hey guys, this is acservicetech, and today what we're looking at is how to diagnose if a defrost control board is bad and then how to bypass it. Alright, so you're going to use your multimeter and you're going to end up testing between R and C. Alright, and that's this red wire and that's C wire, and you can put your probes right into the back, right here and right here. Now you got to make sure that they are touching the red and C. You could also check right here in these wire nuts to see if you have 24 volts. Then during the call for cooling, you're going to end up on most major manufacturers except for Root and Rheem, you're going to have power between Y and C, 24 volts, and you're going to have 24 volts between orange and blue. Okay, so meaning that this is common. So if this is always hot, you're going to have a common to test for 24 volts. Then you're going to have this is going to be now a power wire, and you're going to have 24 volts between the power wire and common. Once again, Y will be a power wire, and you're going to have 24 volts between the power wire and common. So if that happens, and you make sure that you have your T1 and your Y actually are connected. So let's turn the power off for a second. All right, so we've turned the power off, and now we're going to pull the T1 out, and we're going to pull the Y out. All right, with the power off, you can test for resistance. So your multimeter will be set on resistance. I'm only putting it in here just to show you on the camera how to test these wires right here. Resistance, and yet put your probes into each of these wires, and it's going to go through your high pressure sensor, any low pressure sensors, and high temperature limits, and basically you're going to have 0.0 ohms of resistance. That means that all of the pressure switches, and if there's a temperature switch, that they are in the closed position, okay, which means that they're within parameters. Now, you have voltage to the correct wire. So you have voltage to Y, orange, okay, and you're always going to have voltage to red power. So if that's the case and you're not getting a 24 volt signal off of this O right here, from O to C to turn on the reversing valve, and you're not getting power from T2 to C, all right, if you're not getting power by literally reading your probe in the C and the probe in the T2 right here, which can also be measured right here and right here, if you're not getting power, then this control board, defrost control board, is bad. So how to bypass a defrost control board just for cooling? All right, because heating, you're going to run into problems. You're going to run into problems bypassing it because of the fins having frost on them. All right, so what we're going to do is we're going to bypass this defrost control board for cooling, and I'll show you how. All right, so what we're going to do with the wiring here is we're going to first, with the power off, we're going to disconnect this red wire that attaches to the defrost board, and this would be the normal hot wire. We're going to either cut it back and put a blue wire nut, or we can put an orange wire nut. The biggest thing is you just want to make sure that the wire nut's not going to come off. So if you need to fold this wire over in order to do that, go ahead and do that. Fold the wire over, put your wire nut on, and you're good. Now, your weight wire, once again, that can just get disconnected. You could technically leave all of this attached onto the control board, but just for the sake of safety, we're going to go ahead and disconnect them. Your W wire is your heat wire coming off of the defrost board, and it's sending a power to heat for your secondary heat. For common, we're gonna need that. All right, so we're just gonna disconnect this black wire, and since you're not going to have power at your control board, we can just set that in here without a wire nut, but for the sake of, safety's sake or whatever, I'll go ahead and put that in there like that. Your orange wire, we're going to need that. And our yellow wire, we're going to need that. So I'm just going to go ahead and wire nut these and set them back in there. They have no power coming off of them once we disconnect these other taps. There is no power on this defrost control board once you disconnect this red power wire. Okay, even this relay right here that allows 120 volts to go through from here to here, it's not going to have 24 volts to power this relay, so this board will no longer be live after we disconnect this red wire. But I'm just going to put wire nuts on the ends of each of these just for the sake of doing it. Alright, so that's that. We have wire nuts on all of those. So now we have a common coming from our indoor unit. We have a orange reversing valve wire that this one is getting powered in cooling. Okay, this is our Y power for the compressor. Now what we're going to do is we're going to disconnect this wire up here. This is all with the power off. We're going to disconnect this wire here. So this was the common for the contactor, 24 volts, and this right here was the 24 volt power coming into the contactor coil. So it doesn't matter if you have power coming up in here and common coming back out, or power coming here and coming back out up top. You just need to power the coil in order to press this contactor in, and once again the power's off out here and the indoor unit. Okay, the indoor unit's where all the 24 volt power comes from. The outdoor power is basically shutting off this 120 leg and 120 leg here, so that no power will go across when the contactor's pushed. So all the power's off and it's safe right now. So you have those there. Now you have this hot wires going down to a pressure switch. It has to go through the pressure switch in order to have the power come into the relay. The 24 volts will close the relay in order to power the fan over here. The voltage comes in here and then it comes out and powers the outdoor fan. So what we're going to do is we're going to take that off of the defrost control board and power it from the contactor up here. Okay, so we're just going to go ahead and set that down in here, and that's that. We can use some wire management, some zip ties in order to hold this stuff down, but basically there's no power on any of these wires down here on this control board. No power on this, no power on this, and no power on this. You can leave this one attached into there, that's fine. Now what we're going to do is we're going to power the contactor. So we're going to crimp a female spade connector onto a wire, and I'm using the same color code. I'm using Y to turn the compressor on. I'm coming down here, and this is going to get wire nutted to the Y. Then I'm going to take a blue common wire, attach it to the other side of the contactor, come down into the thermostat area right down here, thermostat connection area. And we're going to wire nut that to common. But we're also going to need another common on the reversing valve. With the power off, you're going to go ahead and cut each of these wires. These are for the reversing valve, and you want to make sure that you're cutting them up in the electrical compartment, because you don't want any wires, like wire nuts, down in this area down here where you're going to end up having problems with moisture. So we're going to take this stranded wire and we're going to twist it, and we are going to take an orange wire to power the reversing valve. And then we're going to need another one for the common right here. And we're going to use blue for common. So you're going to take these two wires, you're going to put them into a orange wire nut or a blue wire nut. Every time you put these into a wire nut, you want to test them individually and pull out on them while you're pulling on the wire nut. You're going to feed this down in here. And now you have all 3 common wires right here. You take your other power wire from the reversing valve and you come over to your orange wire for your reversing valve. You're going to use this if you are wiring your thermostat with your orange wire on O, meaning that the heat pump is not a root and ream. If the outdoor heat pump that you're working on is a root and ream and they power the reversing valve in heat mode, then really you do not need to cut the wires to the reversing valve. You don't have to power the reversing valve at all, okay? Because in cooling mode it's non-powered. But in this case, for most other manufacturers, York, Lennox, Bryant, and all them, or a lot of other manufacturers, you do have to power the reversing valve. So you're powering it with hot with the orange wire and blue for the common. It does not matter which way you power the reversing valve. For instance, these 2 wires are coming off. This one happens to be the power, and this one happens to be the common. It does not matter if this is the hot and this is the common, or if this is the hot and that is the common, as long as it's powered. So then you just go ahead and zip tie these up here, make sure that that you're not losing the wires, and you're ready to go. All right, so you have 24 volts on the contactor, 24 volts on the reversing valve, and that's it. So you just need your Y, orange, and blue wires. All right, and you do not need your power all the time. You don't want to power the reversing valve all the time. You want to just power it in cooling mode. You only want to power that in cooling mode, not all the time. Now, next time when you come back and you are reconnecting these, you could use crimp connectors, straight crimp connectors, to reconnect your wires for your reversing valve. Or you could use wire nuts in this cabinet here for your low voltage. But that's how it's done. All right. Hope you enjoyed yourself, and we'll see you next time at AEC Service Tech channel.